Hey guys, we're going to talk about Chapter 20 this week. Chapter 20 pertains to chemical texture services. Chapter 20 is pretty lengthy. We're going to spend 2 weeks on Chapter 20. I'm going to do more than one PowerPoint. I'm going to break this information up for you as easily as possible. So let's go ahead and get started. So let's talk about what you're going to learn. You're going to be able to explain the 4 chemical reactions that take place during permanent waving. Explain the difference between an alkaline wave and a true acid wave. Explain the purpose of neutralization in permanent waving. And you're going to be able to demonstrate safe and effective perm techniques. Also, you will be able to describe how thiorelaxers straighten the hair, how hydroxide relaxers straighten the hair, demonstrating safe and effective hydroxide relaxing techniques, and describe curl reforming and how it restructures the hair. So why do you need to study chemical texture services? So chemical texture services allow the stylist the opportunity to offer client options to change the texture of their hair and to explore fashionable world of hairstyling. If you have curly hair, you want straight hair, you have straight hair, you want curly hair, chemical texture services allows us to do that. Knowing how to perform these services accurately, safely, and professionally will help build a trusting and loyal clientele while aiding in the building of your confidence to offer chemical texture services to all clients. As always, safety and infection control are very, very important, not just for our clients, but for us as well. Especially with chemical services, we are dealing with chemicals. This is the first theory chapter that you guys have had chemicals in this semester. You need to be safe with these, of course. We're going to talk about safety and infection control a lot. We're talking about some very, very strong chemicals when we talk about relaxers and permanent waving lotion. Chemical services are among the most lucrative and repetitive services in the salon. So, lucrative meaning generating income, and repetitive meaning these clients are the clients that continue to come back. Many retail products are specific to hair's texture and condition. So this also allows you to be able to upsell those retail products. Without a thorough understanding of chemistry, cosmetologists could damage the hair, cause hair loss, and harm their clients or themselves. So chemical texture services. The definition of that, chemical texture services are services that cause a chemical change that alters the natural wave pattern of the hair. Okay, we're going to talk about 3 in this chapter. We're going to talk about permanent waving, which is adding wave or curl to the hair. We're going to talk about relaxing, which is removing curl or waves or leaving the hair smooth and straight. And we're also going to talk about curl reforming, or also known as a soft curl permanent. This loosens overly curly hair, changing it from tight curls into loose curls or loose waves. How chemical services affect the structure of the hair. So let's talk about this. All chemical texture procedures involve chemically and physically changing the structure of the hair. This chapter begins by reviewing the structure and purpose of each layer of the hair. Characteristics of the hair that were first discussed in Chapter 11, Properties of the Hair and Scalp. You guys had this with Miss Julia last semester, along with chemistry as well. Actually, in the spring semester, I'm so sorry. So let's talk about the cuticle. The cuticle is the tough exterior layer of the hair. It surrounds the inner layers and protects the hair from damage. Although the cuticle is not directly involved in the texture movement of the hair, texture chemicals must penetrate through the cuticle to get to their target, which is the cortex. Okay. Moving along, let's talk about the cortex and the medulla. The cortex is the middle layer of the hair located beneath the cuticle. The cortex is responsible for the incredible strength and elasticity of human hair. Breaking the side bonds of the cortex makes it possible to change the natural wave pattern of the hair. So the cortex is where it happens, but you have to penetrate that cuticle to get to the cortex. The medulla. This is the innermost layer of hair, often called the pith or the core of the hair. The medulla does not play a role in chemical texture services and may be missing in fine hair. Remember, everybody does not have a medulla. Most people with very fine hair do not. Okay, so let's talk a little bit about pH. And I know, again, Miss Julia taught this in beginners. You guys take it back. Remember, go back to that. You had some activities in beginners in regards to pH, so I'm going to refresh you in that. pH is the abbreviation for potential hydrogen. The symbol pH represents the quantity of hydrogen ions. The pH scale measures the acidity and the alkalinity of a substance by measuring the quantity of hydrogen ions it contains. The pH scale ranges from 0 to 14. 7 is neutral. A pH below 7 is acidic. A pH above 7 is alkaline. The natural pH of hair is between 4.5 and 5.5 on that pH scale. Chemical solutions raise the pH of the hair to an alkaline state. So once you either start with that curl reforming service, the processing solution in a permanent wave, or your relaxer product, it is actually going to take that hair from 4.5 or 5.5 to a very alkaline state. This action opens the cuticle layer of the hair and allows the solution to reach the cortex. That is where the restructuring occurs. So once it opens that cuticle, goes into the cortex, that is where this all happens at. That is where you either go from straight to curly, curly to straight, or you go from really tight curls to softer waves or softer curls. Okay, before I talk about the building blocks of the hair, let me mention that coarse resistant hair with a strong compact cuticle layer requires a highly alkaline chemical solution. So those with coarser texture hair, you may have to use a more alkaline product than just an average product. Porous, damaged, or chemically treated hair requires less alkaline solution. So you have to do, this is why the client consultation and the hair and scalp analysis is very important. You need to know what you're working with so you can choose your product accordingly. Next up is the building blocks of hair. Okay, let's talk about amino acids. Amino acids are compounds made up of carbon, oxygen, hydrogen, and nitrogen, and also sulfur. You'll also see this as CONS, C-O-H-N-S, and that is how I remember it. Carbon, oxygen, hydrogen, nitrogen, and sulfur. Then you have peptide bonds. Your peptide bonds are also known as the N bonds, and they are chemical bonds that join the amino acids together, end to end in long chains that form a polypeptide chain. So here you have your amino acid, you have your N bond that connects it to another amino acid. This entire chain is called a polypeptide chain, and we're going to get into that in the next slide. And you'll see these. This entire thing is an example of a polypeptide chain. So a polypeptide chain is a long chain of amino acids joined together by peptide bonds. Let's talk about keratin. Keratin proteins are long, coiled polypeptide chains. They make up about 97% of the hair structure. Keratin is what gives your hair strength. And side bonds. Side bonds are disulfide, salt, and hydrogen bonds that cross-link polypeptide chains together. And you'll see that example here. You have your hydrogen that link the two polypeptides together, the salt that link the two together, and then the disulfide bond that link the two together. Keratin proteins. Keratin proteins are made up of long chains of amino acids linked together end to end like beads. The amino acid chains are linked together by peptide bonds, also known as end bonds. These chains are called polypeptides. Keratin proteins are made of polypeptide chains, which are comprised of amino acids. Side bonds. Side bonds, the cortex is made up of millions of polypeptide chains, millions, that are cross-linked by three types of bonds. This is your disulfide bond, your salt bond, and your hydrogen bond. Side bonds are responsible for the elasticity and strength of the hair. Altering these three side bonds makes wet styling, thermal styling, permanent waving, curl reforming, and chemical hair relaxing possible. So destroying these and building them back together is what makes this all possible. A disulfide bond. They are strong chemical side bonds formed when sulfur atoms in two adjacent protein chains are linked together. Although there are fewer disulfide bonds than hydrogen or salt, they are the strongest of the three side bonds, accounting for about 1/3 of the hair's overall strength. So there are less disulfide bonds in that cortex, but they are the strongest. Okay, salt bonds. Salt bonds are relatively weak physical side bonds that are the result of an attraction between negative and positive electrical charges. They are easily broken by changes in pH. They reform when pH returns to the normal level. Salt bonds are broken by changes in pH levels. They account for about 1/3 of the hair's total strength. So anytime your pH changes in your hair, so that could be something as simple as shampooing and blow drying your hair. When you lay that client back and use a certain shampoo and conditioner and take that client from 4.5 to 5.5 down or up just a little bit because of the product changing the pH, you're breaking that bond and then you're rebuilding it as you blow dry and thermal or blow dry and flat iron, whatever you're doing to that hair. You're rebuilding that bond. Hydrogen bonds. They are weak physical side bonds that are also the result of an attraction between opposite electrical charges. They are easily broken by water. This is roller setting, wet setting, or heat, thermal styling, and they reform as the hair dries or as it cools. Although individual hydrogen bonds are very weak, there are so many of them that they too account for about 1/3 of the hair's total strength. So there are so many of these. It's not that they're that strong, but there are so many hydrogen bonds that they also account of a third of your hair's strength. So now we're going to actually get into what permanent waving is, the chemistry behind permanent waving, and then we're going to get into the techniques, of course. Permanent waving is a two-step process whereby the hair undergoes a physical change caused by wrapping the hair on the perm rods, and then the hair undergoes a chemical change caused by the application of permanent waving solution and neutralizer. So two things are happening. Physical is what you can see, and chemical is what is happening with those products. Physically, we're taking a perm rod, we're rolling the hair, wrapping it, and when that happens, that is a physical. If I were to take that perm rod out with no product, I'm probably still going to get a curl. That's physical. To make it last, the chemical reaction has to happen. Before I move on to the chemistry part, let's talk about rod size. Rod size determines the size of the curl. And I know you guys are familiar with this because you have rolled a few perms before in your beginner lab. You're actually going to roll a couple more with me this semester, a few more techniques that I'm going to teach you. But rod size determines that curl. The smaller the rod, the tighter the curl. The larger the rod, it's going to be either a larger curl or even it might get into a wave if you're using a really large rod. When performing a permanent waving service, the size of the rod determines the size of the curl. That is the same thing, put it in perspective of using your thermal iron. The size of that rod is the same size curl you're going to get. It's the same thing. It's just different equipment, different products. The shape and type of the curl. The shape and type of the curl are determined by the shape and type of the rod and the wrapping method used. And we're going to talk about those later. Selecting the correct perm and rod wrapping method is very crucial to creating a successful permanent wave. Choosing the right rod, the right product, the type of rod that you use, and also the method in which you wrap it is going to determine your outcome. So in order to please your client, you need to know what your client is looking for and how you can determine that. So let's get into the chemistry of permanent waving. Alkaline solutions soften and then swell the hair and open the cuticle. They open the cuticle, permitting the solution to penetrate inside the cortex. So here, what it does, that chemical swells this, it opens up and allows that chemical to get inside of the cortex. A hair saturated in alkaline solution for 5 minutes, showing the swelling of the cuticle layer. That is an activity that we may do. You also can look at this activity. It is found on page 602. There's an example of this in your book. Hair saturated in an acid balance for 5 minutes. You can see what that looks like. It is also on page 602. And it's here as well. So this is an alkaline solution. Do you see how much bigger this is? It's the same picture, but it's showing you that this is swelling, alkaline, and an acid is not. It has far less swelling. Okay, the reduction reaction. Once in the cortex, the waving solution breaks the disulfide bonds through a chemical reaction called reduction. A reduction reaction involves either the addition of hydrogen or the removal of oxygen. The reduction reaction in permanent waving is due to the addition of hydrogen. So once you get into the cuticle, you're going to break those disulfide bonds. This is called reduction. In permanent waving, in general, what we're doing is adding hydrogen. That is what is chemically happening. Okay, before we move on, I'm going to talk about a few other things. Permanent waving process reactions. So the disulfide bonds, I'm just reviewing, joins the sulfur atoms, creating 2 adjacent polypeptide chains. The sulfur atoms attach to the hydrogen atom, breaking their attachment to each other. So we're breaking that disulfide bond. The polypeptide chains are then going to reform. Once the disulfide bond is broken, the polypeptide chain will form into a new curled shape. Reduction breaks disulfide bonds and oxidation reforms them. So when we're adding that hydrogen, what happens is oxidation. So once your disulfide bond is broken and your new curl, so physically you have curled this perm, you wrap the perm, and just say they had straight hair, and which if they're getting a perm, most likely they do, they have straight hair. Now that you've wrapped it, we know it's going to be curly. So chemically what happens is that disulfide bond is broken and then a new bond is formed, and it's formed in the shape of whatever you have wrapped, whatever the size of the rod is, whatever the method that you've used to wrap is. So reducing agents. Reducing agents commonly are referred to as THEO. THEO is used in permanent wave solutions. It contains thioglycolic acid, which is a particular group of compounds, along with carboxylic acid. Thioglycolic acid. It is a colorless liquid with a strong, unpleasant odor. It is the most common reducing agent in permanent wave solutions. So that is what you smell from a perm, is that thioglycolic acid. The strength of permanent waving solution is determined primarily by the concentration of THEO. So depending on how much THEO is in that product is how strong that product is. Stronger perms have higher concentration of THEO, which means that more disulfide bonds are broken compared to weaker perms. Ammonium thioglycolic. The addition of ammonia to thioglycolic acid produces a new chemical named ammonium thioglycolic, which is alkaline and is the active ingredient or reducing agent in alkaline permanents. The degree of alkalinity. The alkalinity of a perm solution should correspond to the resistance, strength, and the porosity of the cuticle layer. So again, that is your hair and scalp analysis and your client consultation. Is their hair resistant? What is the strength of their hair? What is their porosity? Next up, we're going to talk about the types of permanent waves. We have alkaline waves, acid waves, true acid waves, acid balanced waves, exothermic waves, endothermic waves, ammonia-free waves, THEO-free waves, and low pH waves. An alkaline wave or a cold wave. Cold wave is just what we used to call them a long time ago. Alkaline wave is what you're going to find on the manufacturer's directions. They were first developed in 1941 using ammonium thioglycolic. ATG is the short term of that. They became known as cold waves since they process at room temperature without adding heat. They usually have a pH between 9 and 9.6. And why I'm telling you this is because your client, when you go to pick a product, you need to know what type of product that is and match that product with your client's hair. Acid waves. GMTG, glycerol monothioglycolate, is the main active ingredient in a true acid and acid balanced waving lotion. It has a very low pH and is the primary reducing agent in most acid waves. A true acid wave. They were introduced in the early 1970s. They usually have a pH of 4.5 to 7 and require heat to speed the processing. They have 3 separate components: waving solution, activator, and neutralizer. The activator tube contains glycerol monothioglycolate, and acid waves process more slowly and do not produce a firm curl as alkaline. So yes, your alkaline are going to give you that crispier, tighter, that depends on your rod, but they're going to give you a stronger curl versus your acid waves. It's a stronger product. A pH of 5 is neutral for hair, 4.5 to 5.5. Because pH is calculated on a scale in where a pH of 7 is 200 times more alkaline than the pH of the hair. Therefore, acid waves can swell the hair. Okay, let's talk about acid balanced waves. They are permanent waves that have a 7 or neutral pH. Because of their higher pH, they process at room temperature and do not require added heat or hair dryer to process. They produce firmer curls than true acid. Exothermic waves. They create an exothermic chemical reaction that heats up the solution and speeds up the processing. All exothermic waves have three components: permanent wave solution, an activator, and a neutralizer. The permanent wave in solution contains THEO. That's the main active ingredient. The activator contains the oxidizing agent, which is usually hydrogen peroxide. Mixing an oxidizer with the solution causes a rapid release of heat and an increase of temperature in the solution. Heat increases the rate of the chemical reaction and reduces the processing time. So your heat is actually built into this product. It heats up as it processes. Endothermic waves. They are activated by an outside heat source, usually a conventional hooded dryer. They will not process properly at room temperature. So you either have to put this under a dryer, or you can use the processing lamp that we have, the new processor. And I always remember this, guys, because the question that everybody gets wrong is, what is the difference between endo and exo? Endothermic waves. I remember the letters EN in the dryer. That's how I remember it. Exo is built into the product. Endothermic, you have to put them in the dryer. So ammonia-free waves. They use an ingredient that does not evaporate as readily as ammonia. So there are very little odor associated with their use. THEO-free waves. They use an ingredient other than ATG as their primary reducing agent. Even though this is a substitute, they are still THEO compounds. Although it is a THEO-free wave product, it is often marketed as damage-free. However, this is not necessarily the truth. At a high concentration, the reducing agent in THEO-free waves can be just as damaging as THEO. So even though it's THEO-free, it is still, the primary reducing agent is still a substitute for THEO. Used enough, the amount of it, it can cause the same amount of damage. Low pH waves. Use sulfates, sulfites, and bisulfites present to an alternative to ATG. Sulfites work at a low pH. Permanents based on sulfites are very weak and do not provide a firm curl, especially on strong or resistant hair. Sulfite permanents are usually marketed as body waves or alternative waves. Okay, so I've just given you all that information, and you're probably like, well, what do I do with it? So you're going to have to still take your client's scalp and hair analysis and what they're looking for and select a perm type for them. And this is also in your book, table 20-1 in your chapter 20. So permanent waving processing. The strength of any permanent wave is based on the concentration of its reducing agent. The amount of processing is determined by the strength of the permanent wave solution. The amount of processing should be determined by the strength of the solution, not necessarily the processing time. Most processing takes 5 to 10 minutes. Additional time allows the polypeptide chains to shift to a new configuration. Let's talk about overprocessed hair. and it's not what you would think. I want you to look at the picture really well as I'm describing this overprocessed hair. It does not mean that it's overly curly. You would think if I process this perm entirely too long, then it's going to be extremely curly. That's not the case. If too many disulfide bonds are broken, the hair will be too weak to hold on to that curl. It also may be completely straight. The hair at the scalp is usually stronger, and then at the ends, overprocessed hair is usually curlier at the scalp and straight at the ends. And that's what you see in this photo. So let's talk about underprocessed hair. If too few disulfide bonds are broken, the hair will not be sufficiently softened and will not hold the desired curl. Hair at the scalp is usually not curly as it is at the ends. More processing will make it curlier. So this means if you do not process long enough. So let's talk about thioneutralization. So what happens when we're neutralizing? The process of stopping the action of the waving solution and rebuilding the hair is what happens in thioneutralization. So that processing solution has been on the hair, however your manufacturer's direction says, and those disulfide bonds are broken. So in order to rebuild them and stop that processing solution from working, that is exactly what your neutralizer will do. Your neutralizer is going to deactivate the waving solution if there's any left in the hair. You'll see in the procedure that you're going to rinse before you neutralize. You're going to rebuild the disulfide bond into a new shape. And that's what it does. Neutralizers are oxidizers. The most common neutralizer is hydrogen peroxide. Concentrations of this will vary between 5 volume and 10 volume. So let's talk about stage 1 of neutralization. The first function is to deactivate the waving solution that remains in the hair after rinsing. So after you have processed, you're going to rinse for 5 minutes is what the procedure says. Just rinse. Rods are still in the hair, you're just rinsing. Rinse the hair for 5 full minutes, then you're going to towel blot the hair thoroughly. Blot each rod several times using dry towels. If directed, apply a pre-neutralizing conditioner. Some products come with this, some do not. Again, manufacturer's directions. This is an acidic liquid protein conditioner that can be applied to the hair and dried under a warm dryer for 5 minutes or more prior to neutralization. This is beneficial for damaged hair. Again, always follow your manufacturer's directions, and you may not always have one of those. If you do have one, you're going to rinse it with warm water. Use a very gentle stream. Avoid pressure on the rods. Rinse very fragile areas first, which is typically going to be the front and around the face, but that depends on your client. Thoroughly rinse the nape area and the bottom rods. Rinse for the recommended time. Smell the hair. Continue to rinse if needed. Again, you'll be able to smell it because, as we all know, that processing solution smells like rotten eggs on a good day. Gently blot the hair with a towel. Check for excess moisture. Look especially at the nape of the neck. Blot thoroughly prior to neutralizing. And adjust any loose rods before we do so. Okay, stage 2 of neutralization. The disulfide bonds are now broken. The waving solution again breaks the disulfide bonds by adding hydrogen atoms to the sulfur atoms in the disulfide bonds. Okay, then the disulfide bonds are going to be rebuilt. That is what thioneutralization comes in and does. It rebuilds those disulfide bonds by removing extra hydrogen atoms. The hydrogen bonds then attract oxygen into the neutralizer and release their bond with the sulfur atoms and join with the oxygen. Then a water molecule is then formed. Each oxygen atom joins with 2 hydrogen atoms and rebuilds one disulfide bond to make one molecule of water. The water is then removed. Water is removed in the final rinse, and the disulfide bonds form in their new curled position. So after you neutralize, and typically most of your neutralizers are 5 minutes long, again, that depends on the manufacturer's directions. After you neutralize, you're going to rinse again for 5 minutes. As you're rinsing, that disulfide bond is building back together, and it's taken the shape of the rod and the wrap that you have created. Side bonds are then reformed. Side bonds are reformed into their new shape as different pairs. Most processing time takes 5 to 10 minutes. Additional time allows polypeptide chains to shift to a new configuration. Again, most are 5 minutes. I have seen a few that are 7 minutes. Read your manufacturer's direction. So let's talk about permanent waving procedures. Preliminary test curls. Preliminary test curls are used to determine how the hair will react to a perm. This also helps us prepare, what is the correct processing time. It is used to determine the best processing time for the best curl development. So again, before I wrap this whole head and I process it, I can just do a test curl. It is expected results from the solution. So once it processes, that's pretty much what I can expect on the hair. Curl is expected from the rods and the wrap. That will tell you, if the client wants a tighter curl or if they want a looser curl all over. You can adjust your rod size, or if they want a crokinole wrap or a spiral, if they don't like the direction of the curl, you can change your wrap. How much color will be removed if the process of the client has color treated hair, and this does happen. If clients have color on their hair, it is going to strip a little bit of that color off. If clients both color and perm their hair, I tell them, do the perm first, and then 2 weeks later, do the color, because if you do it the opposite way, it's going to strip a little bit of it, especially if you have a client that's maybe redheaded or has red artificial color on their hair. It could lighten it up so much that it becomes pink, and that's not what we want. This also, the preliminary test curl, allows us to say, will the integrity of the hair be too compromised? Definitely do this if you're not sure what's going to go on that head. If you're not sure if their hair is strong enough, if they have the strength, the elasticity, their porosity is not where it needs to be. Did the hair break? Is it dry? Is it frizzy? Over-processed? Under-processed? You're looking for all of those things so that you can adjust your formula, or maybe even say, it's not a good idea that we do this on your head. Is the client satisfied with the shape and the hold of the curl? Okay, let's talk about the different types of rods. Concave rods. They are the most common. They have a smaller circumference in the center and a larger circumference in the ends. This is the blue one that you see in the slide. They produce a tighter curl in the center and a looser, larger curl on either side of the strand. And I believe this makes, it's not so uniform, it's more of a blended look. It looks more natural, I believe, with a concave rod. A straight rod is what you see here, the yellow, the orange-red rod here in the slide. It is equal in diameter along the entire length of the rod, or curling area. They produce a very uniform curl along the entire width of the strand. Then you have bender rods. Bender rods are usually about 12 inches long with a uniform diameter along the entire length. They are soft foam rods with a stiff inner wire that allows them to take on a variety of shapes. These are very popular. These are very easy. The kicker here is because they are foam, they cannot be disinfected. That is why we do not have any here at the college. They cannot be disinfected. If you have a client that suggests these, I used to have a client that wanted nothing but these. I did not supply them. I could not keep them at my salon because, again, they could not be disinfected, so I shouldn't have any on me. But I allowed her to bring in her rods, and I would use them on her hair. Then you have what we call loop rods, also known as a circle rod. They are usually about 12 inches long with a uniform diameter. They are ideal for wrapping extremely long hair. When fastened together, they form a circle. Again, it depends on what they are made out of to see if they can be disinfected or not. Let's move on to end papers. End papers are also known as end wraps. They are absorbent papers used to control the ends of the hair when wrapping. When wrapping, papers should extend beyond the ends of the hair to keep them smooth and straight and to prevent fish hooks. A fish hook is a hair that is bent up in the end. If you do not prevent your fish hooks, then you're going to have some straight hairs hanging out after you have your wrap done, and that's not what we want at all. So you have 3 different kinds of wraps that you can do with these end papers. The first one is a double flat wrap. Personally, this is what I use. This is how I was taught. It's easier for me. You can use whatever works for you. A double flat wrap uses 2 end papers, one placed under one and one over the hair strand. Both papers must extend past the hair ends. And what I mean by that is this is the hair ends right here. You can see the papers need to extend past that, not here where the hair is sticking out. Then you have a single flat wrap. The single flat wrap uses one end paper placed over the top of the strand of the hair that is being wrapped. You see that in the middle picture of this slide. Then you have a bookend wrap. That uses one end paper folded in half over the hair ends like an envelope. Pre-folded wraps or large end papers which can be folded are available. This eliminates excess paper and they can be used with shorter rods or very short length of hair. Sectioning for a perm. So let's talk about panels. Panels, the size, the shape, and the direction of panel is based on what type of wrapping pattern you're going to create and the type and the size tool that is being used. Okay, your panels are going to be your sections. It's the same thing. Your base section are subsections that are built into these panels. So that is when a panel is divided. That creates a subsection, also known as a base section, for permanent wrapping. One rod is normally placed on each base section. Base placement. This is something that I have recently spoken to you guys about, I will say in everything that we teach, thermal curling, roller setting, pin curls, and of course chemical waving, this is probably the hardest that students, they can't wrap their mind around. This is the hardest thing for them to understand. So base placement refers to the position of the rod in relation to its base section, determined by the angle at which the hair is wrapped. So you have on, you have half off, and then you have off base. On base, the hair is wrapped at an angle of 45 degrees beyond perpendicular to its base section. The tool is positioned on its base section, so 45 degrees beyond its base section. And if you need me to demonstrate these, I definitely can do that for you. And half off base placement of the hair is wrapped at a 90-degree angle. A 90-degree angle is perpendicular to its base section. The tool is positioned half on its base section. The positioning minimizes stress and tension on the hair. Off base placement, the hair is wrapped at an angle of 45 degrees below perpendicular to its base section. The tool is positioned completely off the base section. This creates the least amount of volume, and the curl pattern begins away from the scalp. So those are very important things that you need to know. You don't want to wrap somebody on base that their hair is a little compromised anyways, because we don't want their hair to break off. Half base placement is very safe. Off, again, you're going to get that off the scalp. The curl is going to begin a little bit below the hair strand from the scalp. Let's talk about base direction. Base direction refers to the angle at which the rod is positioned on the head. This can be horizontally, which you see right here, vertically, which you see right here, and diagonally, which you see right here. It also refers to the directional pattern in which the hair is wrapped, backward, forward, to one side. Wrapping against the natural growth pattern causes excess stress that may damage or break the hair. We don't want to ever wrap against the normal wave pattern. Let's talk about wrapping techniques. A crokinole wrap. A crokinole perm wrap is when the hair strands are wrapped from the ends to the scalp in overlapping layers. The curl is tighter on the ends and gets larger nearer to the scalp. And you can see an example of this right here. Then you have a spiral wrap. In a spiral wrap, the hair is wrapped at an angle other than perpendicular to the length of the rod, which causes the hair to spiral along the length of the rod like stripes on a candy cane. This wrapping technique causes the size, diameter of the curl to remain constant along the entire length of the strand and produce a uniform curl from scalp to ends. Okay. Let's talk about wrapping patterns. Wrapping patterns and different types of rods are combined to create a wide variety of specialized perm wraps, thus providing an unlimited array of styling options. Your book covers a few of these wrapping patterns. There is an unlimited amount of wrapping patterns. You can even create your own. A double rod wrap, also known as a piggyback, is used for extra long hair. The hair is wrapped on one rod from the scalp to midway down the hair shaft, and another rod is used to wrap the remaining hair strand in the same direction. This allows for better penetration of the processing solution and for a tighter curl near the scalp that can be provided by a conventional crokinole wrap. Then you have a basic perm wrap, and here's the example of the double rod piggyback, and we're going to do that this semester. You guys have dealt with a basic perm wrap. A basic perm wrap is also known as a straight set. It is a wrapping pattern in which all the rods are within a panel, move in the same direction, and are positioned on equal sized bases. All of the base sections are horizontal and are the same length and width as a perm rod. Base control. Base control is the position of the tool in relation to its its section. This is determined by the angle in which the hair is wrapped. Again, this is on base, half off, and off base. Okay, let's talk about the curvature permanent wrap. The partings and bases radiate through the panels and follow the curvature of the head. The wrapping pattern uses pie-shaped base sections in the curvature areas. Okay, a brick-lay permanent wrap. This is very similar to the actual technique of bricklaying. Base sections are offset from each other, row by row, to prevent noticeable splits and to blend the flow of the hair. It can be used with a variety of sectioning, base control, base directions, wrapping techniques, and perm rods. I'm also going to talk about a few more that the slide does not cover. You're also going to learn this semester is called the weave technique. This is using zigzag partings to divide base areas. It can be used throughout the entire perm wrap or only in selected areas. The technique is very effective for blending between perm rods with the opposite base direction. It can also be used to create a smooth transition from rolled areas into an unrolled area of a partial perm. And that's mainly what I use the weave technique before in the past, is to transition from rolled to unrolled. And this will make sense if you have a client with maybe really short hair in the back and then they have a lot of volume up front, such as men or women with very short haircuts. We talked about this a little bit earlier, but I'm going to go over it again. The double rod wrap, or a piggyback is what I like to call it. It is whereby extra long hair is wrapped from one rod from the scalp midway down the hair shaft, and then another rod is used to wrap the remaining of the hair strand in the same direction. The upper half strand is wrapped around one rod, and then the lower half of the same strand is wrapped around the second rod in an alternate direction and stacked. Again, you use that on really long hair. Spiral wrap, we talked about this a few moments ago. This is also something you're going to do in this semester. It can be used with a variety of base sections, base directions, and wrapping patterns. Base sections may be either horizontal or vertical length of the hair and do not affect the finished curl. Conventional rods, bendable, soft foam rods, and loop rods can all be used for this technique depending on the length of the rod of the hair, and also whether that rod can be disinfected or not. Talk about partial perms. So why would I get a partial perm, or why would anybody get a partial perm? If your client wants a perm but does not wish to have the entire head to be curled, a partial perm may be the answer. A partial perm allows for the client to be given a perm when some of the hair is too short to roll on rods. This can be used for male and female clients who have long hair on top and in the crown, but very short hair with tapered sides and a nape. Clients who only need volume and lift in certain areas. Clients who desire a hairstyle with curls along the perimeter, but a smooth, sleek crown. Partial perms rely on the same techniques and wrapping patterns as those other perms, but there are additional considerations. There has to be a smooth transition between the sections. In order to make a smooth transition from one rolled section to the unrolled section, use a large rod for the last rod next to the unrolled section. Also, using a weave technique there will help out. You also want to protect that unrolled hair. Applying waving solution to the unrolled hair may straighten or make it difficult to style. To protect the unrolled hair, apply a protective barrier cream to the unrolled section before applying waving lotion. So they're not talking about your base cream, but you can take cholesterol and put on that unrolled hair so it is not affected by your process and solution. Let's talk about perms for men. Many male clients are looking for the added texture, fullness, style, and low maintenance that only a perm can provide. Perms help thin hair look fuller, they make straight or coarse hair more manageable, and they help control stubborn cowlicks. Although men's and women's hairstyles may be different, the techniques for permanent waving are essentially the same. And let's get into the safety of this. Okay. Safety precautions for permanent waving. Always protect your client's clothing. Have the client change into a gown or use a waterproof shampoo cape and double drape with towels to absorb accidental spills. You guys know in North Carolina we do have to double drape. We do have to have that chemical cape on our client. Beware of previous allergies. Do not give a permanent to any client who has experienced an allergic reaction to a previous perm. Complete a hair and scalp analysis. Always examine the scalp before a perm service. Do not proceed if there are any skin abrasions or signs of scalp disease. Check for damage. Do not perm hair that is excessively damaged or shows signs of breakage. Do not perm relaxed hair. Do not attempt to perm hair that has been previously treated with hydroxide relaxers. It will break off immediately. Check for metallic salts. If there is a possibility that metallic hair color has been previously used on the hair, perform a test for metallic salts. Use protective cream. Always apply a protective barrier cream around the client's hairline and ears prior to applying the permanent waving solution. Use as directed. Do not dilute or add anything to the waving lotion or neutralizer unless specified in the manufacturer's directions. Keep waving lotion out of the client's eyes. In case of accidental exposure, rinse thoroughly with cool water. Always follow the manufacturer's directions. Wear gloves when applying the solutions. That goes for the processing solution and also the neutralization solution. Immediately replace cotton or towels that have become wet with solution. Do not save any open or unused waving solution neutralizer. When not used promptly, these chemicals may change in strength and effectiveness. So it's not something you can use on another client. You have to discard as soon as this is done. Again, the strength and effectiveness starts to decline. Hair that has been permanently waved should be shampooed and conditioned with products formulated for chemically treated hair. They're talking about at-home products here. So I mentioned metallic salts a while ago, but we did not really talk about metallic salts. Some home hair coloring products contain metallic salts that are not compatible with permanent waving. Metallic salts leave a coating on the hair and may cause uneven curls, severe discoloration, or hair breakage. Metallic salts are more commonly found in men's hair colors and are sold for at-home use. How do I test for metallic salts? In a glass or plastic bowl, mix 1 ounce of 20 volume peroxide with 20 drops of 28% ammonia. Immerse at least 20 strands of hair in the solution for 30 minutes. If metallic salts are not present, the hair will lighten slightly and you may proceed with the service. If metallic salts are present, the hair will lighten rapidly. The solution may get hot and give off an unpleasant odor, indicating that you should not proceed with the service. All right, guys, that is all for chemical waving. I'm going to do another slide on chemical hair relaxers. But I think I've given you an hour of that information. Make sure that you are reading your chapter along with this. Again, this is a lot of information. I realize that. It is a lot of difficult information, a lot of chemistry. And we are going to review this in class as well. Thank you.